The question: an object is thrown vertically upward with a speed of 30 meters per second. The velocity of the object half a second before it reaches the maximum height is. The given data: initial velocity u is equal to 30 meter per second. Body is thrown vertically upward. So suppose this is the ground. A body is projected upward projection with initial velocity u is equal to 30 meter per second. The velocity of the object half a second before it reaches the maximum height. Suppose this is the maximum height. At maximum height the final velocity 0. When it is moves downward, its initial velocity is 0. So the velocity of object half of the second before it reaches the maximum height. So this is the maximum height h. So body is thrown upward, half of the second reaches the, this is the, so remaining half it reaches the maximum height here, and it is projected up and moves downward. So we know here the velocity at this point A is equal to the velocity of the B moves downward is same. So we easily calculate in case of freely falling body. So at the C point, C to be easily calculated, we know the time from here to here half of the second, and here to here also half of the second, because T is equal to half and moves freely, therefore initial velocity u is equal to 0. So from equation of motion, v is equal to u plus at, so in which v initial velocity is 0, a value is the g, t of, or v is equal to, g is the 9.8, t is the half of the second, or v is equal to 9.8 by 2, we get 4.9 meter per second. This is the answer. The first option is the correct one. The question: the deceleration of a car traveling on a straight highway is a function of its instantaneous velocity v, given by w is equal to a root v, where a is constant. If the initial velocity of the car is 1 meter per second, the distance the car will travel and the time it takes before it stops are. In the question, the deceleration means negative acceleration, that is a is equal to negative acceleration. Deceleration means this is a negative acceleration, but is given w is equal to a root v. This is the negative acceleration, and the initial velocity of the car, initial velocity u is equal to 1 meter by second, 1 meter per second. So the distance traveled by the car, s is equal to how much, and time taken to before stop, t is equal to how much. So for distance s, for determination for s, for determination of displacement, the acceleration is right in the form of displacement. So we know the acceleration a is equal to, so minus means deceleration, a is equal to, we know that is v dv by ds. Okay, this is the acceleration formula in terms of displacement s. So it is substitute here, therefore v dv by ds is equal to, the minus you should write here, a into root v. So v dv by root v is equal to minus a into ds. Then v root v, this is the v power, this is minus 1 by 2 into dv to minus a ds. So v power 1 minus 1 by 2 is the 1 by 2 into dv minus a into ds. So then integrate on both sides. Integrate on both sides. Integration v power 1 by 2 dv is equal to integration a into ds, but here limits initial velocity to final velocity. So final velocity is 0, initial velocity is the 1. So initial position is, that is s is equal to 0, and final position is the s. So integration v power 1 by 2. So v power 1 by 2 plus 1. So v power 3 by 2 by, so 1 plus 1 by 2, 3 by 2. So limits, so v is equal to 1 to 0 is equal to, a is the constant. So here a is the constant, integration ds value is the s, limits 0 to s. So therefore, so 2 by 3, so 0 minus, here the negative value is there, minus, and here also minus. 2 by 3, 0 minus 1 is equal to as. So 2 by 3 minus 2 by 3 is equal to minus as. Minus minus gets cancelled. S is equal to minus 2 by 3 a. meter. So finally we get the displacement s is equal to 2 by 3 a meter. Next, for time. So for time, the negative acceleration, nothing but deceleration a is equal to, I can write minus a is nothing but omega is equal, w is equal to dv by dt. This is substitute in this equation. So w is the minus dv by dt is equal to, the given equation is a root of v. So dv by root v is equal to minus a into dt. Integrate on both sides. So v power 1 by 2, we get minus 1 by 2, integration dv, a is the constant, integration dt. So limits v is equal to 1, v is equal to 0. Initial velocity, final velocity 0 for a deceleration. And v power 1 by 2 minus 1 by 2, minus 1 by 2 plus 1, 1 by 2. V power 1 by 2 by minus 1 by 2 plus 1 also 1 by 2. So limits from v is equal to 1 to 0 is equal to a, the time t is equal to 0 to t, the limits in integration. Therefore we get t, so 0, this is the t, this one is 0. Okay, finally now this is a negative, a 2 upward, 2 is equal to, we get minus 2 I think, is equal to minus of a t, minus minus gets cancelled, t is equal to 2 by a second. This is the time, this one is displacement, s is equal to 2 by 3 a. So our fourth option is correct one. This is the fourth option, right answer.